All right, so thank you guys for having me on here. My talk is about using Lidar to find to find areas to actually treat on otherwise flat floodplains. And so I'm from Norfolk County Mosquito Control in Massachusetts. By way of geography, we are located in south of Boston, south and southwest of Boston, ranging from somewhat urban areas, grading into suburban areas to more rural areas over by the Rhode Island border. So my main goals of this presentation is to explain what LIDAR is, and I want to show some very similar flood events that have occurred in which we have attempted to treat the floodplain, and I want to show how LIDAR actually really helped us pinpoint exactly where to treat on the floodplain. And I want to show the results and some new questions that were raised. And as of this is the third time I've given this talk, and as of this year, 2020, we have some new data to provide for how it worked out this year. I wanted to note too that this isn't actually a scientific study. What had happened is when we had done one of the aerials here, I had suddenly discovered that our requests had gone way down in a certain area, and it actually helped me to find out that the way we had actually done the aerial that particular year really helped with the amount of requests. So we didn't really have any trap sites already set where we could, do a control and all that. And the timing of the traps was also very inconsistent. So it's not really a scientific study. It just kind of almost fell in my lap in a way. So LIDAR stands for light detection and ranging. And according to NOAA, it is a remote sensing method that uses light in the form of a pulsed laser to measure ranges, variable distances to the Earth. So what happens is a plane goes overhead, it's shooting the laser down, and it's able to pick up on basically the shape of the land, the topography of the land, and it can also do it underwater with the bathymetry as well. It gives you highly accurate elevation data. Sometimes the data can be as accurate as 5 to 25 centimeters, and you can really get a low, a low interval on the data as well. Many GIS-related websites have it available for free, including our own MassGIS. Usually they give it to you in raw form, so you have to actually have some GIS and remote sensing knowledge in order to convert the data to fit whatever it is you're looking for out of it. So here's an example of the LIDAR, and what I did here was I circled a couple of areas. This is a salt marsh, so it's a very flat area. And here's a little pond right here, and down here we have a little stream. And if we overlay the LIDAR data at 0.1 meter intervals over it, we can see that it is showing up in the elevation on here very, very well. And I can just do that one more time so everyone can see that. So a little bit about the Neponset floodplain. Obviously, it's along the Neponset River. And the floodplain itself is about 6 miles long by 1 mile wide and covers 6 of our towns. It can be a prolific producer of 80s Vexans and Sorophora ferox, but also pretty decent amounts of Stichticus and Trivitatis as well. And now we're beginning to find out that it also produces a lot of Canadensis during certain times of the year. And we have some suburban neighborhoods that abut right up against this floodplain, so it can be a major problem should we get a flood on it. This is the river right here, starts down in Foxborough, pretty much right behind Gillette Stadium, and then heads up through the middle of our district and then empties out into Boston Harbor. This is an elevation map. It starts out around 300 feet above sea level here, makes its way down, and then completely flattens out when it hits these towns right in here. And so this is the floodplain that we're talking about right in here. It's about 40 to 50 feet above sea level, so there's no ocean water getting in there, so any problems we would have here would be entirely fresh water. This is a wetland map of the floodplain, so these would be all the areas that would be wet if the river was at its maximum height. So this fairly expansive area, and like I said before, butting right up against it are multiple suburban, pretty densely populated suburban neighborhoods through here, including some really highly affluent neighborhoods up in here that really let us know when there's a problem going on pretty quickly. I'll also note too that there's an airport sitting right here, sitting right in the middle of the floodplain as well. So it actually has a rain gauge, which I'll get into in a minute. So we're able to get how much rain is actually falling directly on this floodplain. We have 2 traps set in it. One is University Road Trap, which is a very rural trap. It's out in the middle of the woods, basically, right in the floodplain. And then we also set another one fairly recently right here at the edge of the suburban neighborhood, so we can get an idea of what's happening in these neighborhoods. And finally, there is a USGS river gauge just upstream off the map here. And over the course of probably at least 10 years, we've been monitoring this gauge, because over time we began to find out that it was actually a really good predictor as to what was going to happen on the floodplain with the mosquitoes. So over time, we found out that if the river at any time during the mosquito breeding season goes up to 7 feet, we end up with a minor outbreak and a localized outbreak of mosquitoes. It's usually not a big deal. Usually the woodsy areas around these neighborhoods will have a lot of mosquitoes, but they kind of drift into the neighborhood, but they're not out of control or anything like that. That changes dramatically at 8 feet. We end up with a significant neighborhood infestation of mosquitoes. The calls go through the roof in this area, and it can get pretty bad pretty quickly. 9 feet I have yet to experience and really don't want to. That is a major multi-town outbreak of mosquitoes. Not only will all the mosquitoes be in the neighborhoods, but they'll actually drift outside of those neighborhoods into other parts of the town that normally don't see too many mosquitoes. 9 feet is actually considered flood stage on this river, and it's important to note that a lot of the times that you see flood stage, really that means that's the point at which property damage or property inundation will occur. The river floodplain itself can get flooded well under flood stage. So you get a mosquito outbreak, but you're not getting any property damage at that point. So generally of gauge height, when it goes above 8 feet, it will trigger an aerial larvicide. And I think that's happened almost every time it's gone over 8 feet. We've gone out onto the floodplain and seen a lot of mosquito breeding going on. So
I'm sorry, Nate, can I interrupt for a second?
Sure.
Your the volume on your microphones keeps on going down a little bit. I'm not sure if you're at some distance from it or if they're, I'm not really sure, but just so you know, it's a little hard to hear you at some time.
Oh, okay, thanks. Can you hear me now?
Yeah, a little bit better, sure.
Okay.
Thanks.
Let's see. Yeah, a gauge height of 8 feet or above will likely trigger an aerial larvicide after we've done surveillance down there. And the problem that we always end up having is, where is the water on the floodplain? When you, just because it's up at 8 feet doesn't mean the entire floodplain is actually flooded. So the wetland boundary maps that we have actually show the maximum extent of flooding, as I mentioned earlier. So even though it's at 8 feet, large areas will be really too dry, and some areas will actually be deep as well, too deep to breed mosquitoes. So the question has always come up: do we treat it all? Do we make an educated guess as to where the water is, treat it, hope for the best, or end up taking angry ULV requests? And even in some cases, we've had some of our employees go up in the helicopter when the treatment is going on, saying, look, there's water, treat that. Obviously, these aren't the best ways of doing this, so we had to find another way. So here are some examples of not the best ways of doing this. In June of 2013, we had a flood in June, early to mid-June, where the river went up to about 8.5 feet. Sure enough, we found plenty of mosquito breeding going on. And we thought at that time, the best thing to do here would be to treat the edge. So on June 13th, we had the helicopters go out and basically treat about 2 or 3 swaths along the edge of the wetland. And we figured that would probably take care of much of the mosquito problem, and also head out from the edge a little bit, just in case the water isn't quite up to the edge. These were the requests on July 3rd, a little time afterwards, right before July 4th, unfortunately. So the request went out of control. Clearly, our aerial did really pretty much nothing in this floodplain, and so this ended up being a nightmare. Probably went on for several weeks. Our University Road Trap did end up reflecting this. By June 23rd, there were over 13,000 mosquitoes in that trap. 99% of those were Vexans and Ferox. Unfortunately, that's a trap that I always have to collect, so I can remember this day very well, of going out when I went out there to grab that one. And even a week later, there was still over 10,000, 86% Vexans and Ferox. But interestingly enough, we noticed that some Canadensis had actually started showing up in the trap as well, which kind of raises an eyebrow as to whether or not canadensis actually is a new hatch in this area that we would not have expected. So moving ahead to April of 2018, we had another flood event. This was a bit earlier in the season, mid-April. Typically, we figure that you're not going to find too much Vexans or ferox at that point. They're more of a summer floodplain species. So while this was interesting that the river went up that high, we figured it really probably wouldn't be a major issue. So we decided to do nothing here in terms of larviciding. That proved to be a mistake. By May 30th, these were the number of requests that we were getting from this area. Now, May 30th was our official first day of spraying in this region. So the reason I have second ULV up there is because about a week and a half to 2 weeks prior to this, the phones were ringing off the hook from this neighborhood, and we had to send a truck out prior to the beginning of our season to spray these areas. So even after we did that, these were all the requests that were still there. So clearly ignoring the situation in the spring was also not a good idea. Our trap numbers reflected this. We're using Ledgeview here, which is right up against the neighborhoods. And we apparently were getting a canadensis and Stichticus problem at the time in here. So this was kind of a little bit of an eyebrow raiser as well, that just because it isn't summer, we're still going to have mosquito problems in these areas on the floodplain. So now we're up to 2019. This was almost an identical situation to 2018. Mid to late April, went over 8 feet, and this time we decided we had to do something about it. And this is where the Lidar comes in. So in order to properly treat the area, we figured, well, why don't we use some of the Lidar data here and try to really pinpoint where we're going to treat on this wetland. So here's the elevation map of the floodplain in half-meter intervals. And what we did was we sent out our employees to check out various spots along the floodplain, armed with a map, various spots along it, walk out, show me where the water is on this floodplain on the aerial photo that I provided. So we did that, and miraculously enough, everyone came back with the water level being at the exact same spot. And generally it was right where the yellow meets the brown in all these areas. So from that, we were able to make a treatment area here from that information. A couple things to note, this green right here was not treated because we figured that was just too deep. And then there were other areas we left out up in here of the yellow we left out, which were Phragmites and things like that, and didn't figure that there would be really any breeding coming from there. So April 30th, we did the aerial larvicide and with Vectorbac G, covering that area there. And these were the requests at the beginning of June during our first night. So certainly a lot less than it was the prior year, 2018, certainly a lot less than it was in 2013. And just to compare apples to apples, this was our second ULV that year. And the requests had obviously come way down. So yeah, there were some mosquitoes, one ULV took care of it, end of discussion for that area. Trap numbers back that up. Ledgeview, remember the night there with Ledgeview had over 3,000 in 2018. Now it was down to only 153 in June 3rd of 2019. So same typical species, canadensis and Stichticus that were in dominance there. However, this time we also had some Vexans showing up as well. So here's just a direct comparison between the traps in 2018 when we did no treatment, and 2019 when we did using the Lidar. So basically, the results were very promising, certainly with the request numbers that we were getting, and the mosquito numbers seemed to back that up as well. So, and also we noticed, while Vexans and ferox are a problem in the summer, we're now starting to wonder that canadensis and Stichticus have a mid to late spring floodplain, and we can't ignore any flooding on this river during that period of time due to the canadensis and Stichticus. And then the final question I'd had is, will this work with a summer flood species? Lo and behold, as luck would have it, if you want to put it that way, we were able to figure that out this year. On June 28th of 2020, 3.64 inches of rain fell at that airport I showed you on the map in 2 hours. There was a very brief water level spike to 9.5 feet on this river, and it was above 8 feet for 3 hours. So it was kind of a flash flood situation. It wasn't like a major flooding situation, but we had sent our crews out to check out anything, any water, standing water on the floodplain. And sure enough, there was some, and it ended up starting to breed mosquitoes pretty quickly. And by July 2nd, we had helicopters in the air treating the areas. Again, we used the Lidar to try to really pinpoint exactly where to treat. And these areas were somewhat smaller than the prior areas due to the flashy nature of this flood, not creating, a lot of widespread water, but some pretty serious breeding in areas where there was water. I put the traps on here this time. Ledgeview is shown here. University Road, you'll notice, was not treated at all. And that's because it was actually on the private property owner there is vehemently against us doing any treatment whatsoever, either adulticide or larvicide. So in a way, it ended up actually acting as a control site for us at University Road, whereas Ledgeview down here got treated. So this, I thought, was kind of interesting information. Here were the trap results after the flood. University Road is in blue, went up over 10,000, 96% of those were ferox. And Ledgeview, while it went up to 3,500, certainly a lot less than University Road, 69% ferox, 22% Stichticus, and it ended up dropping off fairly quickly afterwards. As far as requests, I'll go through this real quick. July 8th request looked like that. July 15th, a little uptick. We went out and sprayed it. By July 22nd, the requests had basically come down to normal. So compared to this was a direct comparison to 2013. If you remember, this whole map was covered with requests. Certainly this seemed to help really well. Using the LiDAR to really pinpoint where to treat here helped really well in this summer situation as well. So that's basically it. Thank you to everyone for having me, and